Hello and welcome to this webinar. Thank you for joining us. This is a micrographics webinar. Today's topic will be best practices for detailed drawings and documentation. This is going to be mainly about your drawing workspace in Inventor Professional. And there's a lot of features there that people are sometimes not fully aware of and not able to make the most out of it. So we aim to clear up any misconceptions about drawing and also advise you what's the best practices for getting detailed drawings. Okay, we will begin the webinar in a few minutes. We're just waiting for more people to join. So in about 60 seconds, we should start. Okay, I think some more people have joined and everyone is settled, and I can see people are asking questions. So yeah, we can go ahead and start. Okay, so just an introduction about me. My name is Irshad Hanif. I'll be conducting this webinar. I'm an application engineer with Micrographics. I come from a mechanical engineering background with about 8 years of experience in industry and 2 years of experience as an app engineer in the Autodesk channel. So I've been using CAD software for a while and working for the past couple of years with Autodesk and 2 years specifically as an app engineer with the Autodesk channel. Okay, so my design experience is primarily with AutoCAD, Inventor, Fusion 360. Of course, I do product data management with things like Vault, as well as more advanced engineering workflows and tasks such as FEA analysis and CAM for either Inventor CAM or Fusion 360 CAM. So I have a fair bit of experience in the Autodesk workspace. Okay, so our agenda for today, basically we're going to start off with an introduction. We're going to do a quick recap on detailing a drawing. Then we're going to move on to iProperties and templates, just to show you how to get the best out of your text and your attributes in your drawing templates. We're going to discuss a little bit about tables and parts lists. Then we're going to look at form management, and then we might dabble onto incorporating iLogic and custom parameters into your drawing templates. Okay. So, section 1. We're going to start with views, and we're just going to discuss about it, basically a recap on how to manipulate views when you're placing your drawings in, and it basically how you place a base view and the options that you have around aligning it horizontally, vertically, making relationships between the base view and the linked views, rotating at angles or absolute edges. So you can pick a point and you can rotate it about that point. You can scale it up, you can give it a name, and also when you break links, you'll be able to it will automatically create a named section view, or not a named section view, but a named view. And from that, you'll be able to place your linked view at any point, anywhere going forward. Okay, staying on views, with section views, you'll be able to basically dissect your part, right? And you'll be able to choose which point of view you're looking from on that design, you'll be able to create a section line, as you see there in the diagram, section AA, and you'll be able to detail that section line by simply dragging that cutout view to an opposite end, and it should be in line with your drawing. Okay, you can also use key areas in one cut, and remember, section views can be as simple or as complicated as you need. You're not limited to one straight line. You can do a sort of zigzag line or a line at an angle, and we will demonstrate that shortly. And in fact, let us jump to Inventor now and demonstrate that quickly. Okay, so now that we're in Inventor, we can simply go start a new drawing, or we can open up an existing. I'm not sure if many of you are familiar with this workflow, but we can always open up. I'm just going to go and open up something like a design that I have here. I'm going to say update my assembly. All right. So you don't necessarily have to start by creating a new drawing of your design by going to new and say I want to create a new drawing, or opening up this whole menu and then placing the base views. You can simply right click on the assembly or the part that you want to create a drawing of, and you'll be able to go here and say I want to create a drawing view of that, and it will ask you to select your template, and we can say create. Okay, I have on this template just some added field in here, so I'm just going to enter something in there. Yes, styles have been changed, so we're going to say okay, and it's going to ask us to place the initial view. Just going to go home so that we can get the front view. Right, as per your dialog box, you've got your styles. I'm going to remove that, and I'm going to place some views here, just so you can see what we're talking about. Okay, of course we can edit our scale, so we can say 1:10, or we'll make it slightly larger, 1:8, and then we can say okay. Now you'll notice that the base view was the one that we first placed, and everything else is linked. So for example, this is also linked, and they all copy the styles of the original base view. Okay, I can right click, however, on one of the views. Remember, the 3D isometric view is free to move because it is not linked in any linear fashion, so it's not linked as the left hand side or the top view. These you'll see that they are linked, but this is not. So here you can say edit view, and we can change whatever we need to. Okay. I'm going to do that again. I'm going to say edit view, and I'm going to now change what I need to on, for example, if I wanted to make it from the north east side or northwest side, looking like so, and I can change it to be a different style. I've got that on there. All right. Now also, like I said, these views are linked. We can simply right click on one of the views and say break link, and when you do that, it will insert a view called AA, and will label that such that anywhere you move it, you are easily able to identify where that view is looking from and where it's taken from. Right? So that indicates the projection of what that view is. Okay. Now you'll notice that I've chosen to include the hidden lines in here. So I've also got the option to remove the hidden lines, but these don't look too good because, well, the dashes are too big. And I'll show you exactly how to change those hidden lines to be maybe light gray solid lines. I prefer that, so we can always take a look at it like so. As is, these are just the hidden line removed views, so you won't see whatever's behind the diagram here. Okay. Also, like we said, we do have the option to align, well, realign it. So we can say, I want to align this horizontally with that, and it should go back in place. Right, so we have the option to align it like so, horizontal like so, and now it's fixed, and it automatically removed that section because it's now saying, hold on, this is linked, I don't need to align anymore. Then we also got the option to rotate and move these things about. So for example, I can rotate this by an edge, and I can flip it around, or can rotate by an absolute angle. Okay, so I can say, right, let's enter maybe 25 degrees. So I can tilt it by without having to affect the model or the related parts. Okay. I'm not going to save any of that. I think as is fine. Okay. And lastly, we just want to take a look at your named styles. So you do have the option to put in the label here and say test label 1, and we can say I want to actually edit the label, put it in there. I need to turn it on. I do apologize. I was supposed to say turn my label on so that you see the label, and there we go. It's labeled to say this is what you're viewing, and that is the scale of what you're viewing. Okay, so those are basically best practices that you want to do. So let's go back to our PowerPoint. All right. Then we've also got breakout views where we can create a closed loop section of what we want to do. So we've got, besides section views, we've got breakout views. So let's take a look at those two in the next example. So section views are when we can create our own section line. So we can choose the object we want a section. And remember I said you can simply draw a line of where you want a section. Say right, continue. And we can move either to the right or left of this line that I created, and it would section that. You can see that if I move to the other side, it's going to section. We'll see the arrow pointing the other way. Now remember that this is very customizable. I'm just going to place one of these here. Okay, but I did say as before, you can make section views as complicated as you need to. So for example, if I do a section view on that area and I start drawing like so, actually no, that's not going to work. Maybe I should do it better. I'll do it again. Click on that. I'm going to do it like so. And then I can say continue. And I'm just going to do a section around that line. It's going to take some time to calculate exactly what I've cut through. And then you can see that it is now cut through that area. It's still taking some time. Let's just give it a minute. So you can see that it's cut through exactly the line that I've gone through, even though it's a zigzag line across an uneven part of the section. So I can scale that to maybe 1:1. want it 12. Just make it a little bit smaller. And we're going to just wait a few minutes for this to kick in and save itself. And there we go, we have a unique section based on our section line, and it shows there with its labels. Remember, each of these can be edited, so we can go in and edit label view, and we can go in and maybe change the styles of it. We're supposed to do this. There we go. All right. So that's section views. We also have breakout views where we've got to create a close section loop, for example. Well, you've got to draw your close view first. So I'm going to go here. And I'll say finish sketch. And now that we have a closed loop, we can say, right, I want a closed loop, and I can say, well, I want a breakout view from, I can choose a point on any of them, or I can choose to sketch to hold through part. And I can say there, 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 there. Okay. Let's give that a few minutes to calculate. And it's going to ask us we want to create a breakout view. So you can see that we've done a breakout view of that whole section there. Now those sections are removed based on what I clicked. So if I've undone that, you can see the difference that it has made from what I selected. And we can go back to our PowerPoint. Okay, so the next section we'll be discussing standard symbols. So if we want to insert stuff like surface symbols or well symbols or any indicator for datum, you can insert them here from the standard library, or you can create your own. So you can create your own custom symbols. They will be saved as blocks. So blocks are the same concept as from AutoCAD, where you have a little predefined saved line diagram. It could be a polyline, could be just a random bunch of circles and arcs and sketches. Okay, and it will save this under a folder called sketch symbols, as you see on the left there. Okay, so let's just take a look at that. I go to annotate, and just to indicate that a normal weld symbol will look like so. You can say, okay, I want to weld over there, and you'll input your data. I'm just going to enter anything in here, and you'll see your different type of information there. However, there's also the button here to insert a sketch symbol from an external block. It'll ask you to select something from the library, or you can create a new symbol. How does it work? Well, the moment you click define new sketch symbol, it'll take you to the sketch mode where you can go in and sort of draw a new type of block. So I'm going to draw a new block, just illustration. And let's just, yeah, that looks okay. Right. And I'm just making this symbol up as I go along. Okay. So that's the moment you click finish sketch, that's my symbol. And you'll see now that it will give me an area to enter a name for that symbol. So random symbol. I'm going to save that, and it saves it under the folder sketch symbol as I've indicated before. So what does that mean? That means we can simply right click on that and either save it to my symbol library, where I'll be able to use it again. So obviously I've got to create a library if I don't have one, but in this case I do have one in my library, and I can see other stuff that I have here. And I can save that so it goes in there for later use. And I can also pull it into my design any way that I want to. Okay, and that's it. So that's how you create custom symbols if you are not using the standard ones from the Inventor library. Okay, that brings us on to the next section. We've saved our custom symbols. Okay, now we want to look at model dimensions or how to make use of the different types of dimension in Inventor. Okay, so you'll see that in your Annotate tab in Inventor, you've got your regular dimension, you've got baseline, and you've got your options to arrange your dimensions. So you've got baseline, ordinate, and chain. So let's just take a look at all of them. So let's just look at a regular dimension. We know that we can have one of three input methods, either from point to point. It's going to give us that, which works well. Or we can just dimension a line. So a complete line that it finds, it will dimension that. Or you can dimension between lines. Or you can dimension between two lines at an angle, and it will give us the. So actually that didn't work, but maybe if I do some angle like so. There we go. So between two lines at an angle, it will give us the angle between those two lines. Right. We've also got baseline, which does an initial line for us, and then we can select all relevant lines. Right click continue, and you'll see it will use that initial line as a reference and everything else in relevance to that. We've also got ordinate and chain. So chain is similar to how we have baseline, except it will put all the dimensions in between as opposed to referencing from that initial line. So for example, if I did the same thing here, 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 and right click OK, you'll see that it will try and squeeze. Obviously the size isn't that too good. Let me try and do better with the, I'll say from here to here, to here, to here, and you'll see that it will insert a chain link of dimensions. Just wanted to neaten that up quickly. Alright, great, and now we have a set of chain dimensions. Okay. Okay, we've just discussed the types of dimensions. I'm just going to move on to the next section. View representation. So we do know that in your Inventor model, if I take a look at our model, let us say that there is something that we don't want to take a look at. So you do have all your views placed here, but if there's a particular assembly or sub-assembly in here that you don't want to have included in your drawing, you need to make use of your view representations. So for example, I can suppress a collection of parts, let's say those two shafts. I can right click and say suppress them. The moment I do that, okay, I need to save it first. The moment I do that, it's going to create a new level of detail for me, and it's going to say level of detail 1, and that's with the, I can always move back to master where that's in, but the moment I, just to illustrate again, the moment I block off anything and suppress it, suppress, it's going to say a new level of detail, and I can save that. So it will ask me, you'll notice that there's a new dialog box when I save remove shafts. Say okay, and now we have a custom representation there called remove shafts. Why is that important? Well, let's say we were in our drawing again, and oops, it's getting stuck a little bit. Right. Let us add in a new sheet. Yeah, just let's say we were placing a new base view of our drawing. We can choose which representation we want. So remember, I have master, all content is expressed, and the new one that I created, remove shafts. And if I place it on there, you'll see that now the view gets in without those two that are removed. So it's a very useful tool to block certain parts that may be in the way when you're giving your design out. Okay. I'm going to go back and activate my previous sheet. Okay. So just to recap some notes on the view representations. So view representation control component visibility and transparency, sketch and work feature visibility. So you can also have your work planes and your sketch. Okay. The selection status, whether it's enabled or not enabled. Okay, the appearance style and characteristics applied in the assembly. So that's what they also govern. We're also looking at magnification, viewing angles, etc., etc. So you can turn up the visibility of components, but it does not remove them from your view tree. Okay, it's the components are still there; they'll still appear in your RAM and your BOM and all of that. However, they will not be removed. They're just being suppressed. Okay, so when a component is set to transparent in the assembly, transparency is carried over in associated drawings. Okay? So the notes have just skipped over to the line. Just excuse that. Okay. Component transparency in the drawing view must turn off the view associated. So level of details is very similar. So level of detail representations improve capacity and performance. They suppress unneeded components or replace many parts with a single part representation to reduce memory consumption and simplify the model. So you'll see your Inventor. In your model, you have not just your representations, but your what we just discussed, right? You have your different level of details, as I've just shown you, but also you will have your views. So I can create, for example, a new view, and I can edit that view to maybe select a bunch of components or a bunch of things that I don't want. So I can say select to include, and I can say select priority or whatever it is. I can view all excluded. So remember, whichever ones are being hidden or invisible. For example, here there's a bearing that's not shown. etc., etc. Right. So I've actually shown this to you in reverse as according to the notes, but the idea is still the same. You have level of details and views. Okay, we're just going to go back to our PowerPoint. Okay, so detailing your drawings and managing your styles. Okay, here's where most people get confused. A lot of times we'll get inquiries from customers asking exactly how to change something as simple as their arrowheads or their text size, and whatever they do doesn't seem to want to work. So let's take a look at how we would change those things. So we can see that in our current template, everything is just sort of black and bland, but nothing has been customized with our styles. So arrowheads are quite large, text is quite large, and they don't seem to match. So in the Manage tab, you'll find your styles editor. Okay, if I click on the styles editor, it does take a little bit of time to open. We're just going to wait for it to load. Okay, so here we are. You'll see that in your styles editor, you have multiple sections for each type of drawing attribute that you can change. So for example, your hatch, your dimensions, your center mark, and each of these have various options. So how does all of this work? Well, in your standards folder right at the top, you'll be able to create a standard that will define basically whatever combination of styles for your example, for your balloon, for your dimension, for your hatch, for your layers, etc. and so on. Okay, so I'm going to start, in order to change some of these, I'm going to start by creating a new standard. Now you'll have to click on one of the options in standard. You can't click on standard. Reason being, it bases it on whatever you're clicking on. So for example, if I click there, it's going to base it on that. So I'm going to start here, new style, and give it my custom style. Okay. Best practice to use a format that you're familiar with or a standard that you're familiar with. Set up your millimeters or your units, and then you'll be able to take a look at all the available styles that you have. You'll notice here that you have all the actives, all the styles in the active standard, or all the local styles, or all styles that it sees in the entire workspace. So whatever is available with Inventor, including the ISO, DIN, NC, and so on, you'll be able to see that. I'm just going to look at the all styles. Right. Now I'm going to go here to my new style. I'm going to make that the active style. You see that it's now bold, which means I can come in here and customize exactly what I want to see. So for example, for dimensions, I can choose a different style for the way I see dimensions. So how do I make a new style? Well, I'll have to go to dimensions and make one. And I'll just look at default new style. Okay. My dim style. Okay. You'll see the checkbox there was add to my new style, or add to current active style, meaning it adds it here so that I'm able to see it. My new dim style, there it is. Let's go back there. And you'll see that I'll be able to change exactly what I want to on my dimension. So for example, I can change my text size to, I can change the display, maybe just 1.5. Yeah. Let's just change that. We can change the color. Let's make it blue. Okay, the text, you'll use the primary text style, or you can use a text style that you create. So you can create a new text style. It'll take you directly to the new text style, and you can say, well, I want a text style of 2 more, height 2 more, a different font, and perhaps a different color. Let's make it blue as well. So I'll save that. Oh. In fact, maybe we should, just for illustration purposes, we'll make a new style. Just so that we can identify it. Again, I'll do the color to blue. I'll do the height to 2. And I'll say save. That way, when I go to my dim style, I can choose the text to be my text. Okay. So you'll see that the size of the text gets grayed out because it puts it to whatever was in my text style. Okay. And I'm done with that. So now I can go back to my new style and just ensure that, yes, I want to save all of that. So let's go to dimension and say the style that we're using for dimension is my dim style. I'll save and close. And you'll see that now that we've changed the size of the arrowheads, and we've changed the font, and we've changed the text, anything else I want to change, I can go back in there and say, right, I'm not happy with the dimensions, or maybe I want to use a different type of arrowhead. Let's just wait for this to load again. Okay, so it is loaded, and we can check, okay, what is my new dimension style? Let's take a look at that. My dim style, display. That's that. I'm just going to look at our, so we can change, we'll see we have options for how our tolerance is displayed, our option for the placement of our arrowhead. So we have lots of options to replace the extension lines and how the notes and leaders are displayed. So everything can be changed in this manner. So I'm going to save and close that and move on to the next thing in the slide. Okay, so tables and parts list. That's pretty straightforward. We can look at the best practices, which is to use, you don't have to draw a parts list, you can use whatever's in your bill of materials. So Inventor has a bill of materials included in there. You'll notice that it's this button here. And let me just say that again. Our bill of materials looks like so. Okay, and each of this data will be passed on through to our drawings. So how does that work? Well, let's activate a second sheet. And we can use our parts list option to create a new table and insert, okay, which object do we want to use as the base for the BOM. And we can choose whether it's a what type of BOM level. So parts only, structured, and first level or all levels. We're going to put all levels, structured. Okay, and we can say, all right. I'm just going to move that in there. There's quite a lot of parts in here. And you can see that we can resize this as we need. I'm just going to place that in here. So if we want to edit the parts list, this is how we'll do it. We right click edit and we can change stuff from here. So we can take a look at filtering out stuff, sorting them, exporting them, and fiddle with our table layout. So for example, we can define how we want the title and the styles to look. So you can say I want that to be text. And we can change things like line spacing, just say okay. You'll see that now it's changed to the text that I just edited. Okay. You also have an option here to renumber and reorder them. Okay, you have an option to select your columns. So for example, if there's specific iProperties you want to show on your table, you can do that. Okay. And remember, the size is based on the text sizes and etc. that we put on here. So that is how you would use your BOM parts list. If you look at, so we basically covered creating a new table, creating a new parts list, and editing your BOM. Okay, custom iProperties and property entries. So if you look at our drawings, so I have a pre-made template on here. Let me just show you what that looks like. I'll create a new drawing. Perhaps I should choose the correct project. Okay, so we're going to discuss the custom iProperties on your template. So you can see the extent of your template, what's possible. I have created a custom template for an example for clients. And you'll see that I went through my styles editor and changed everything that I needed to for my title block. So if you look at my drawing resources, I customized my border, my title block, and if I edit something like so, you'll see that I have a whole bunch of interesting things here. Now, this is not necessarily a tutorial on how to do everything. I mean, that will obviously be covered in training. However, you'll notice that I have left space for custom things such as revision number or reference number, and I've got a mix of attributes and regular text, right? And I've managed to combine these, right? So if you look at, I'm not going to save anything here. If you look at my manage tab, a lot of people don't know this, but there is what used to be here rather. Manage. Oh, there it is. So the parameters that's normally in your drawing view is here in your manage tab. And what you're able to do is you're able to create some custom parameters, and that way you can create a drop-down list for selecting these options here. So for example, if you go in your sheet size, you can have a drop-down list and say, okay, the sheet size I want to C, D, A, B. right? You can even use these in conjunction with iLogic to have rules-driven inputs. So, for example, here I've got okay, well, file name is just regular text. Job number you can enter in here. Let me see if we've got. You can create a form using iLogic, and each time you create a drawing, you'll have this full form open here, so you can enter the client detail, the site detail. You can say from a drop-down list, who was it checked by, who was it approved by, etc., etc. So that's just a very advanced way. Of course, again, this is a combination of years and years of training on not just how to make a template, but also how to use parameters and how to use iLogic to create forms. And this is the end result of what you can have. Okay, so that brings us to the last section on the webinar. So I'm just going to move on to the last slide, which is basically our Q&A session. So if there's any questions, we will leave this section open. And you guys are welcome to type your questions in the bottom right in your team viewer. We're going to leave this open for a few minutes just to get any questions, or you're more than welcome to take down my details from the beginning. So maybe I should just navigate to that first slide. So you can ask for me. I'll just leave this on at the beginning. That's my details. And yeah, you can ask for me at Micrographics, and we will be able to assist you if you have any questions. Okay, with that, if no one else has any queries, we can end the session, and thank you for joining us.